Okay, 6.2, solving quadratic equations by graphing. So rigorous thinkers and learners will be able to solve quadratic equations by graphing. Here's the deal. When you graph something, it's going to cross the x-axis one of three ways. Either crossing it twice, crossing it once, which means the vertex is right on the x-axis, or not crossing it at all. These are what we call the roots. So we either have two roots, one root, or no root. So when you set a quadratic equal to 0, you are assuming it has a root. The roots, or the zeros, that's another term for it, because it's when the y equals 0, are where the graph hits the x-axis. And these are the solutions to that equation. So what I mean by solving. So if you come up with two answers, then there are two distinct real roots. If you only come with one, then there's just the one at the vertex. And if you don't come with any, that means that they must be complex numbers and that there's no such thing as there's no real solution for them. So let's go. See what I mean by this. So here we got something, we're going to graph it. Remember what we do here, we got to find the vertex, and we do that by first finding the axis of symmetry, which is negative b, negative 6, over 2 times a, which is 1. So x here equals negative 3. So let's go ahead and graph that axis of symmetry at negative 3. Okay, now to find the vertex, oh, my bad, I almost forgot. This thing starts off as saying x squared plus 6x plus 8 equals 0. It doesn't say y, so we're going to create a related function for this guy. Let's call it f of x, because we're going to graph this thing, not this thing. But we're going to find out when this thing equals 0 by seeing when it crosses this axis, and that'll tell us when it equals 0. That'll give us the solutions. So, since we're finding the f of x here, let's find the f of negative 3 now, since we know that's where the axis of symmetry is. Well, that's negative 3 squared plus 6 times negative 3 plus 8, that's 9, plus negative 18 plus 8. That's the same thing as 17 minus 8, or negative 1. So f of negative 3 is negative 1. That means our vertex is at negative 3, negative 1. Okay. That means right here is a vertex. And we know right away that it opens up because this is positive. Now this is one of those tricks that we can use. Because there's no number in front of the x squared, this means it's going to go over 1, up 1, over 2, up 4, so on and so on and so on. So, over 1, up 1, over 2, up 4, and that's going to be on both sides here, and over 3 squared is 9, so we're going to go up 9. So that gives us a pretty accurate drawing of this parabola. Now, all of that wasn't even what we're really trying to do. What we're really trying to do is find out when this thing equals 0. Well, it equals 0 when it crosses the x-axis. So it equals 0 here and here. So this thing, we can say that x equals, looks like negative 4 and negative 2. And that's actually my answer. Those are my two solutions for x. And I found them by graphing. So try this one. The only thing is, it's not ready to be graphed. You got to first set it equal to 0, then find the related function. So let's do that together. Let's say I was to subtract 16 from both sides. I'd end up with negative x squared plus 8x minus 16 equals 0. And I would call that the related function f of x and graph just that now so that you can find that. So go ahead and graph that, do the same thing we did over there, find the axis of symmetry, then find the vertex, and figure it all out. I'll give you a few seconds. You may want to pause the video and then check back for the answer. Okay, so there's my vertex. You should have gotten at 4, 0. When I solve for the axis of symmetry, I get that the line x equals 4. This is not to be confused with your solution of what x equals for your answer. This is just the equation of the line of the axis of symmetry. That's what the x equals negative b over 2a is. And then when you plug 4 back in, you get a 0, so my vertex is 4, 0. When I graph it, it's one of those normal just x squares, so I go over 1, down 1, over 2, down 4, over 3, down 9, same thing on this side. And you get a nice, beautiful parabola that only crosses the x-axis right here. So my solution for this guy is just x equals 0. That's the solution. I can plug in a 0 and this whole thing will cancel out and work. So that's only one solution. So remember, here I had 2, here I just have 1. So let's do a third one and see what happens here. It says use a quadratic function to find two real numbers whose sum is 6 and whose product is 10. Well, or show that no such numbers exist, then graph the related function. Well, let's think about this. Let's two numbers whose sum is 6. Let's do x and y. X plus y equals 6. And let's just solve that for y. Subtract x. Subtract x. So we get y equals 6 minus x. And then we need the same two numbers whose product is 10. So we need to go that x times y equals 10. Well, we can take this equation and just plug it in for y. And that would give us x times 6 minus x equals 10. Okay, so we want to see if we could solve this. Remember, we're going to solve by graphing. So let's try and get this thing in a nice, neat, orderly fashion. That's the same thing as 6x minus x squared equals 10. We could subtract the 10 from both sides and write it in standard form. So I really have negative x squared plus 6x minus 10 equals 0. Alright, well, in order to graph this, I have to find the related function. And that just means I say like f of x equals. Sorry, my handwriting's a little weird here. So we got f of x equals this whole thing. Well, now in order to graph this thing, right, we're going to have to do the same thing we've been doing. We're going to have to find the axis of symmetry. So let's zoom in and take care of that. The axis of symmetry again is going to be when x equals negative b over 2a. Negative b in this situation would be negative 6 over 2 times my a. My a in this situation would be the number in front of the x squared, which is just negative 1. So this is like negative 6 over negative 2, which is the same thing as just x equals 3. Alright, got my axis of symmetry. Let's go ahead and graph it. And since I have my axis of symmetry, I know my vertex is going to be somewhere on that line. So now I just need to find f of 3. So that was what the function is when you plug a 3 into it. So f of 3 equals negative 9, because you're only squaring the 3, plus 18 minus 10. That's a negative 19 and a positive 18. That makes a negative 1. So f of 3 is negative 1. Alright. Well, that means that we have a vertex at 3, negative 1. So let's plot that. That's right here. And we can tell by looking at the function that it's negative, so it's going to curve down. And it's just a regular x squared. Oops, just a regular x squared. So it's just going to follow that normal pattern that we've been talking about, where we go over 1 and then we square 1. So over 1, down 1. Over 2, the square of 2 is 4. Over 3, the square of 3 is 9. And now all we have to do is just connect all these dots. And we have ourselves a parabola. Now we have to ask ourselves, where does this thing cross the x-axis? Well, it never does. So that means that there is no real solution for this scenario. So this whole thing where it says no such numbers exist is true. So we're just going to say no real solution. And later on, we're going to find out how to find the complex solution for that. Okay, for this one, I want you to go ahead and graph it. I'm going to let you guys do that on your own. And then I want you to see what happens when you try to find the solution or the roots of this thing. So go ahead and try it on your own. Pause the video and I'll put the graph up in a second. Okay, when I did this, I got the axis of symmetry is x equals 2. Therefore, the vertex is at 2, 3. So I graphed it. It's one of those easy ones to graph. Follows the normal pattern. 1 squared, 2 squared, 3 squared. And then I noticed that the roots aren't so easy to identify. Look, they're somewhere in between 0 and 1 and somewhere in between 3 and 4. So we have to just kind of estimate. So we could just say something like the roots are between 0 and 1 and between 3 and 4. And that's really as best as we can do for solving something like this. Because they even say, if exact roots cannot be found, state the consecutive integers between which the roots are located. So it's between 0 and 1 and between 3 and 4. And that's all we know so far. We can't get any more exact by graphing. but maybe we can have another solution that gets a little bit more exact. Okay, for the last thing here, I have a word problem that I want us to work on. This is a fairly simple word problem. It says on October 14th, 2012, sponsored by Red Bull, Felix Baumgartner broke the record for the highest jump. This is, you may remember this guy that went up in this balloon, carried this spaceship up to space, and then he jumped out, and wearing like a spacesuit. He jumped out because he literally was in space. So, they give us this formula, and it says that this formula ignores the changes in atmosphere and resistance, but it says that T is the time in seconds, HO is the initial height, and HT is the final height, and calculate how many seconds he would have fallen for if he opened his parachute at 1,000 feet before hitting Earth. Well, we can figure this out, right? So H of T, that's his final height. Well, that would be where he stopped falling. That's when he opened his parachute, so that's at 1,000. Equals negative 16. We don't know for how many seconds. Plus the initial height, which was 128,100 feet. Okay, well, let's just solve this thing. We got to get the TL by itself, so this isn't crazy hard. Subtract 128,100 from each side. And we get negative 127,100 equals negative 16t squared. Divide both sides by negative 16. This looks like a calculator problem to me. And yeah, I end up with positive 7,943.75 equals t squared. Take the square root. Technically, anytime we take the square root, I should put the plus or minus sign there. And also looks like a calculator problem for me. And so I end up with t equals, technically plus or minus, about 89.13 seconds, right? Okay, well, it's not going to be negative time. He didn't fall for a negative amount of time, so he fell for a positive amount of time. So we could just say, and this is a word problem, so we should answer in a complete sentence. We should say that Felix fell for about 89.13 seconds. Now, the reality is he actually fell for a lot longer. He fell for about 4 minutes and 22 seconds. That's because this formula doesn't account for atmosphere and resistance and all this other things. So there's a lot more that goes into the actual falling of this guy. But yeah, pretty interesting to fall for 4 minutes and 22 seconds. Anyway, that's it for 6.2. See you guys on the next video.